full-time on Android since 2008 when the G1 first came out on T-Mobile. Before that, I worked a little bit at Adobe Systems. That's where I got my start on mobile technology, working with Drew and Symbian and all these outdated unused technologies. Yeah. I worked for Steve Jobs and met Steve Jobs at Next Inc. a long while back. And he was, at that time, he was all about cross-platform. He wanted to see Objective-C compilers on any kind of hardware and have your Objective-C programs run more or less the same, no matter what kind of desktop you were seated at. And you wouldn't know from the way that Apple looks today that he was about cross-platform. And so I liked what he was saying and moved out to Sun Microsystems when Java won that battle and became the place to do real cross-platform work. And Scott McNeely talks about how the network is the computer. And I'm really excited with mobile, how we're pushing the network edge out, how we're getting into an Internet of Things. So I have talk about glanceable displays, and I have some code. These 3 cards I'm going to pass around if you've got a computer with you. These are USB thumb drives, and there's a couple of zip file projects from Eclipse and the slides. And if you don't have your laptop, you can email me and get to show me, and I'll be happy to get the materials to you. So I want these back. So glanceable displays have become a very hot topic with the advent of Android Wear. I worked on glanceable displays for Dr. Abby King at Stanford University in the Stanford Prevention Research Program that helped the aging studies. And we created an intervention, and our goal was to get people to sit less and walk more. It was a very successful intervention, and we had people in the Stanford Design School working with us to create these glanceable displays. We designed 3 apps. The one that you're looking at here is a couple of home screen widgets. And what we had was 3 different frameworks, 3 different skins to determine what would really inspire people and motivate them to change their behavior, to walk more and sit less. The apps were cognitive. This one was measurement and goals. You can see the meters showing you your sitting time as well as your activity. Another was attachment, so we created a Tamagotchi to kind of look like a pet. And the third was social, and I have a couple of shots of them. Any idea which one might have been the most successful? I wanted the Tamagotchi myself, but actually it was social. So this one is very good for inspiring engineer types, rational types. What you see here in the meter is sitting time. Most of the wearables that you find out in the market, Fitbit and so forth, are only telling you how many steps you've taken. The other information is pretty important too. So this was the Tamagotchi in a very old Android skin. And the bird would start at the bottom left, and if you got about 40 minutes of physical activity, rigorous or moderate to vigorous physical activity, MVPA we call it, the bird would go all the way up to the top right and fly faster than the jet plane and do barrel rolls and follow your finger when you tap on the screen. That one was a lot of fun to do. It's great live wallpaper. Unfortunately, it's not on the market. And this is our social, our most successful skin, where you see yourself on the top left. You're a little bit larger. Your avatar is a stick figure. All of your teammates are enrolled with you. There's an opposite team, and they are a little bit grayed out. And you can see the various states, and we had 2 animated states. So the number of states in the social skin closely matched the number of states in the Tamagotchi skin. And they would reset to laying down every morning, or flapping its wings every morning. And over the course of the day, as you moved, the Tamagotchi would change to reflect your level of activity. So we had 2 running stick figures, and it was always great to see that on the screen. And whenever you brought up the screen, you would see fireworks either on the left or on the right, depending on which team was winning. So this was a very subtle kind of interaction with the user. And the interesting thing about it is, of course, that the user didn't have any choice. These are glanceable, but as soon as you power on the screen, you're getting this information whether you want it or not. And that, I think, is actually very helpful. So I've got a couple of things to show you. On the left is a sample live wallpaper, and it's not very interesting. It counts your touches and it changes your background. It's not animated, but we'll talk about how to do more interesting stuff. And you've got, a skeleton, that's the project. And on the right is one of the collection widgets. So the home screen widgets from the Stanford project were not collections, and it was great. The home screen widgets that we did were just an image view. It was very simple, very straightforward to position an image view on top of an image view, and it was a very simple composed screen display. And the good thing about home screen widgets is that you can't put icons on top. They don't get blocked. They're always on top in the launcher. The 2 types of home screen widget that I'm going to review with you came out later, and they have a collection of data. And so you can figure out what is important and interesting that you can summarize in a short list or in a few images, and keep that fresh, relevant, interesting information available to your users right on top once they power on the screen. So the user sees the wallpaper every time they wake the phone. It is an essential interaction to quickly make a call or start an app. So with live wallpaper, you have to be very careful not to get in the way. You have 16 milliseconds. That's it. If you drop a frame, then the user is waiting to make their phone call. The user is waiting for to be able to touch the screen and bring up the app that they really wanted to see. So while you could do OpenGL, or putting a fancy game engine, is probably not a good idea. What we're talking about here is 2D canvas drawing. You're gonna get the bitmaps, keep them small, frame by frame animation, and keep it simple and keep it fast. So I didn't really say, so it's a wallpaper service that creates the engine. And typically what you'll do is you'll nest the engine class into the service, because the service doesn't do anything but return the engine. And it will return the engine when the user is selecting a live wallpaper and when the user sets the live wallpaper. And the methods that I've listed here are, the main methods, but you'll notice there's no onCreate. It's onCreate engine. It's not a view, it's not an activity. It's 2D canvas drawing. And I've been told by the Yahoo guys that it's better to use GL surface view, that's faster than the canvas, but I'm not sure they tested that in a live wallpaper engine. So I keep it simple and just use a straight up surface view in canvas. Offsets changed is moving left to right. Visibility changed, that should be patently obvious. You gotta clean up. Don't leave stuff hanging around. Don't, keep checking the GPS or something. surface destroyed and surface changed are kind of the same as visibility changed. And touch, of course, that's the way that you can interact. And use it sparingly because it's very easy for the launcher to mix up a touch to the wallpaper with a touch to app icon. So here's the sample code. And it's, like I said, the engine is inside the service. And typically what you'll do is just have a handler and post delay. And you will post to the handler your drawing method. You can inflate a view. You can create a view structure if that's really what you want to do. But it's not an activity. It's not someplace where you want to try to get users to type. That's not going to work. So, in the example, I used a synchronized array list that is built into Android by default for some values that were changing in the handler loop. I just wanted to point out that this came for free. You can get synchronized Android array lists for free. It's a nice thing to have. And this is it. This is the important thing, and that's really all that you have to do. Post. Inside the draw runner, you post again. So you post the draw runner, which at the end of draw runner posts delay and it calls itself again until the visibility is taken out and you call that. So offsets changed. I wrote a lot about this and I thought it was great and I thought it was cool. And in the sample program, what you're getting is panels on home screen and change the background to different gradients. I got fancy with the gradients. I like that. And then I found out that this offset change is not working. A lot of the manufacturers have broken it. I got used to carrying the Nexus and having things work the way that I expect. But I have learned since then that HTC and Samsung both have issues with offsets change. So the workaround is ugly. The workaround would be to detect the swipe and to identify when the user is changing screens or changing panels using swipe gestures and measuring those in touch event. I think that's kind of complicated, and I think it might be a good idea just to stick with a single panel, and no matter which panel the user is on, show the same panel, which is what we did at Stanford, and it's gonna work no matter what. But you've been warned. If you want to have a continuous background that changes across any variable number of home screen panels, you can, and it's cool. I'm just warning you, it's harder than it looks. And yeah, if you want to try and use the offsets, you have to set the offset notification. What is it there? Offset notification enabled. It's been in the stack since 2011 when live wallpaper was introduced, and I think it got broken in KitKat. So here are some other measures to other methods. In the code, it's just defensive coding for these two to kind of redo the visibility code, just in case the manufacturers are doing something funny. And touch events. So in the code sample that I've given you, it's action down. So when a touch is initiated, you could have it be action up, you could have it be any of the possible touch events. If you've done any coding with touch, then you know that there's different events. And so I didn't want to double count and have action down and action up on the screen. I only listened for the action down. Multi-touch could work. And the motion event data is something that you would need to work with if you wanted to try and read the swipes and the handle changes. And so again, this is from the sample, where all of the code for touch is only in one touch event. But you might have other touch events in response to those. In the example, what I've done is created two different object types. So one of the object types is a simple data structure where you have an X and a Y and a color. The other is a view that has an on-draw method. And so I'm calling them to do the canvas drawing in different ways. In one, I'm calling, just draw a circle as a canvas method. And in the other, I'm cycling through the list of objects and calling draw on an object. And it's 6 of one, half a dozen of the other, whatever works for you. So I want to show it to you. I'm going to see if I can get Droid at screen to come up and I can give you a demo of the code that I've provided. There's my mouse. Sorry, I was just getting a little more interesting than I wanted it to be. I'm not sure if it's going to zoom, but you can see it, right? So this is what we call a stack widget, and it's very cold in London today. You can just swipe through individual images, and so the idea here for this widget is that you're showing a picture of the place, the temperature, and the location. So the collection displayed here in the stack is the same collection that's displayed here in the list. So here in the list, what I've got are different cities with the same information but without the pretty pictures. And then on top, the refresh button will make sure that I have the latest information. And on both of these, I have set an action. And so I can open my app by touching the stack, and I can do the same by touching the widget. And so that's home screen widgets. That's the two that I've provided. I've also got the wallpaper. And so it's counting touches and it's animating, but the background is not changing, which it does on an Nexus, so you just have to take my word for it. And then it resets after a time. And like I said, there's two different types of touches, and the number of circles is a setting. Lots of good stuff in there. So now what I thought I would do is go through the widget code. So are there any questions about the wallpaper, canvas drawing? Anything? Nothing? Okay. Then I'll go back to the slides. I use Droid add screenshot capability is also built into ATB, the Eclipse DBMS view, and there's lots of choices now, but Droid add screen is one that's been around for a while. I don't have the latest version. It might have displayed a little better if I had updated it recently. I got to give a lot of props out to Droid add screen, very helpful. I was able to display Google Glass on the Droid add screen, as well as my Android Wear Watch. So here we go. The examples that I've given you are collection widgets, and they require an adapter. And so I think most of you, assuming some experience with Android, have worked with adapters before. Both the live wallpaper and the home screen widgets are displaying in the Launcher app. These are remote views. This is not your app that's displaying the live wallpapers, the system. And so for that, it gets a little bit tricky. So the lift view that you saw in the stack view have the same collection backing them. And it's typical MVC, where the model and the view and the controller are separated, and the view is a remote view. The home screen widgets have a remote views factory and an app widget provider. The remote views factory is created by a remote views service, and the remote views service is declared in the app manifest. So the remote views factory is your adapter, and instead of get view, you have get view app with an index on the collection. And of course, data set changed. When you create a home screen widget, you create it with an update interval, saying how often you would like the application to check for new data. And that's something that can also be done manually. That's the button at the top of the list. And so on data set change is when the data backing the widget is updated. The app widget provider has two possibilities for changing the view. There's on receive, because it's an extension of the broadcast receiver class that you may already know as an Android developer. And on update is its own call, which is rendered automatically by the interval set in the XML description of your widget class. So these are the manifest entries that are required. You need to have something that's going to receive the app widget update call. And when the user creates the home screen widget, when they drag it and drop it onto the home screen, that's what is called the app widget update. And you have to remember, they can create the same widget twice or 3 times on different panels of the home screen. And that's an important factor. You might have different styles of widget. Then that app widget update receiver class has metadata, and that's where you describe the app widget. That's where you tell the system the default height and width, the default layout, things like that. So the second part of it is the remote views factory. The remote views service creates the remote views factory. I got a little ahead of myself. The remote views service is declared in the manifest, but the work is done in the factory, and typically you put them together in a single class, like the live wallpaper and the live wallpaper engine. The live wallpaper service, live wallpaper engine, remote views service, remote views factory. So the on-destroy is an important place to clean up. You might leave your database open so long as the widget is on screen. It's, you know, a good idea to make sure that stuff is clean so that your app doesn't get killed, because your whole app might get killed if you're being careless with your widget. The getView callback is matched to the getView method in any adapter, and you're going to map the data to fields in the XML layout. So what you've got beyond that is some restrictions. You can't create a layout with every possible object, and custom views are not allowed. So by default, there are a couple of methods, helpers to help you along, and that's set view text view text, or set text view text, and set image view resource. So those are kind of the two expected fields to have in your layout, the text view and image view. The on-click filling intent is the stuff that opens the app. I showed you that both the list and the stack view did the same thing, and that's how it got done. And then you return the view, just like in getView. There's no convert view, there's no view holder. It's not going to work that way. You're going to have to inflate a new view each time. But you're not doing it, the launcher is doing it. This is what it looks like, and I shortened things a little bit here and there to try and make it easier to read. What I am doing in the list view is switching off the background of the text view so that you can see more easily the difference between one row and the next row. And so that's why you have the position mod 2 equals 0. And setting the text, setting the image view, and setting the intent. So I want to open the specific city that was selected. And so I put some extras on the intent so that a specific known value from the data collection can be used when an activity is opened inside the application. We talked about this. There's one more item here to know, the loading view. So if it's going to take a while for you to fetch the data the first time, or to fetch the data on an update, you can display a loading view. Default view says, you know, loading, please wait, something like that. The app widget provider is one of those items that's declared in the manifest that we've been talking about, and on receive is the main method of a broadcast receiver, and it is a broadcast receiver subclass. So in the app widget provider, in one of the examples that I gave you, actions are being specified, and the onReceive provider is being used for the onReceive method, which is built in, is being used for action inside the app. You don't have to use the onReceive provider. You can do everything just using the onUpdate. And so that's another difference between the two examples that I've given you. One is using the broadcast receiver functionality, and the other relies solely on the onUpdate. Stack provider is the one that is relying completely on update, and the list is using the receiver as well as the update. The important thing on this slide, the important thing to notice is the widget ID. So you need to have that set as an extra. So when I look at these these pieces. When I look at the home screen widget, it's a set piece. I'm not sure if you guys are World Cup fans, but soccer uses the term set piece.
Football.
You could call it that. I like football too. It's, you know, it's your special team, so I guess it's a set piece. So if it's a corner kick, there's one guy who always does the kick, and he tries to get it to the other guy who's ready to put it in the goal as a set piece, and they practice the play, and it's the same and the same and the same, and sometimes they get a goal and sometimes they don't, but that's not what I'm talking about here. What I'm talking about here is that it's the same stuff, you know. It's the declarations and manifest, it's the on-update method, it's the get view at method. And it can really be a lot of fun to create these kinds of user experiences. And this is kind of the set piece. It's a for loop. The for loop goes through all of the app widget IDs that are passed in as a parameter. And each of the app widgets is updated in turn with the same for loop logic. So the pending intent. In home screen widget, you have a pending intent template. So the issue was that you have maybe a dozen items in the list. If you set a pending intent on each one of them, it's expensive. Intents are big objects. And so there is provide just the one piece of data that's relevant to that item in the collection. It's not unlike a pending intent, it's not too complicated, but it's a template, it's the same intent on every item in the list. And that's really it. Glanceables are a very exciting place to be. Glanceable interaction is 5 seconds, 15 seconds. It's the moment that the user turns the screen on and powers on the screen. And it's that little small interval of time that you have before they start the app or open the phone or do what they were really intending to do. And it's a challenge to try and fill that very small space with something interesting and exciting. What we did at Stanford was we had a display that changed over time. It wasn't the same. It wasn't all text. It was different almost every time you looked at it. It was interesting. It surprised you. A lot of the mistakes that are being made with these Fitbit applications and with these other wearables are simply that they're boring. I'm getting a message on my heart activity that I'm done, and it's the same every time I finish the 30 minutes of activity. I'm done, and I would like something more interesting. I would like an animation. I would like something that maybe is different for every day of the week. I don't want it to be text. I like having an image that I have to kind of decode. And I see it, and I get the information immediately, and then later I think about what that might mean. And I'm referring to, of course, the Tamagotchi moving across the screen over time. The challenge is really to create context, and I'm not talking about context variables, obviously. It's location and, time and. It's about creating user experiences, putting meaning into the data that you are collecting. Really excited about wearables, even if the displays are kind of monotonous and boring at the moment. The way that it looks to me is that this is where medicine is going, and with an aging population, you've got parents, I've got parents getting older, and the system is a mess and it's very hard to navigate, and it seems obvious that all of these wearables are geared toward health and healthcare. the Fitbit, the Lumo app, all of these apps, there's, and devices, there's brainwave scanners. These wearable sensors are about tracking and measuring your health in one way or another. And so I feel very strongly that it's going to snowball and that healthcare is going to move forward in this direction. Doctors need to have their hands free, obviously. And there's a lot of legal restrictions that apply to the field. But I do think that wearables are where medicine is going, and that glanceables can be a powerful part of that. So maybe one day we'll be in a situation where our doctors are prescribing a sensor and an app instead of a drug. I was wondering if anybody had any questions. I think I have one more slide with some links that might be helpful. So the links are to the study and the programs that I use to build the samples, and of course, Applico. Yes?
Can you make the icons animated or something on the, when you see the normal white screen?
The home screen widgets do not yet support any animation. We manually rotated the arrow on the home screen for home screen widgets. The canvas drawing on the live wallpaper is all frame by frame.